So in part C of the question, we want to know whether the derivative of our inverse is convex or concave. So we want to find out the second order derivative of this whole thing, which means that we consider this our original function now, our starting point, and we have to differentiate it once and then once again. So let's do it. If we differentiate the inverse once, the derivative of the inverse, we differentiate it once. That's the first step. That's the first derivative. Well, remember, the derivative of our inverse from the previous question we found out to be 1 over 2y. So 1 divided by 2y, we differentiate again. Well, what is that? That's the same as saying 1 over 2 times, what is 1 over y? Remember the power rule, that's just the inverse, y to the power minus 1 derivative. We have a product and we have a constant, so we'll keep the constant out and we differentiate only y to the power of minus 1. And what is that? Well, y to the power of y to the power of minus 1 derivative, well, we use the power rule and we bring the minus 1 down. So we have 1 over 2 stays constant times minus 1 comes down, multiplied with y to the power of minus 2, because it's the power rule, we're having minus 1 on the top, and that's equal to 1 over 2 with the negative 1 makes it into a minus 1 over 2 times y to the power of minus 2, which is the same as minus 1 over 2 y squared, because y to the power minus 2 can be written as a fraction. Alright, that was just the first step, the first derivative of the derivative of the inverse, so to speak. Now we have to do that again. So we're taking this result in step 2 and we're differentiating again to find out the second order derivative. So minus 1 over 2 y squared derivative. That's the second step. Well, that's the same as minus 1 over 2 times y to the power minus 2 derivative. Remember, it's a product with a constant, so we keep the constant out and we differentiate y to the power minus 1 over 2. So that's y to the power of minus 2 derivative. Let's go on. That's equal to minus 1 over 2 times, let's use the power rule. The power comes down, so it's minus 2 times y to the power of minus 2 minus 1 is minus 3. Okay, now we can see that 2 and 2 cancels out, 2 and 2 cancels out, minus with minus makes into a plus, so we have positive 1 times y to the power of minus 3, that's just y to the power of minus 3, which is positive 1 over y cubed. Okay, 1 over y cubed, but the question is, what kind of values does y have? Because that's all for the inverse. Well, to know what kind of values y takes, we need to know the domain of the inverse. And to find out the domain of the inverse, we must use the range of the original function. So let's do it over here. That to know what values y takes, we need to know the domain of our inverse function, and that's equal to the range of the original function. Now, what was the range of the original function? Let's calculate it. If we have e to the power of 2x, which is the original function, and we give any values into x, any of them, negative or positive, what kind of results do we have? Well, look, we can get very small numbers. We can have, if x is approaching negative infinity, if x is really small, we will have e to a negative number. E to a negative number means 1 divided by e to that power, and that becomes positive. Well, 1 divided by a big number, that becomes very small. That becomes 0.00001, for instance. But it never touches 0. It only approaches 0. So if x takes negative values, the result approaches 0. But if x takes positive values, the result becomes very large, because we would have x approaching positive infinity e to the power of 2x, it would be a very large number here, and that would also approach positive infinity. So what can we conclude from here? What is the range of the original function? What kind of results do we get out of the function? Well, we get values close to 0 but never actually touching 0, so it's going to be from 0 until positive infinity, and that would be the range of the original function. And if that is the range of the original function, it means that's also the domain of the inverse. That's the range of the original function, and that's also the domain of the inverse. Now, if that's the domain of the inverse, and the second order derivative of what we calculated is 1 over y cubed, 1 over y cubed, which means now that y takes value from 0 until positive infinity. Any value out of this function will be positive because it's going to be 1 divided by a positive number. So that's going to be a positive result. And what did we say? That when a second order derivative is positive, what kind of function we have? If the second order derivative is positive, well, in that case we have a convex function. So the function that we were looking for is convex. And that's the final answer. We are done.